Repetition, as no one in this conference needs convincing, is central to the musical experience. Whether we are talking about formal structures, phrase structures, or at the level of the motive, in a setting like this, it almost seems overkill to have to formally establish that music repeats itself. But if you need to, it's not that difficult. And it's not that music is repetitive, and repetitive in a way that other forms of art and culture are not. Music's repetitive nature, particularly patterns of pitches, are one of the fundamental building blocks to our experience in music. Research from music perception demonstrates quite clearly that these repetitive structures in music are learned implicitly, meaning that our brains, without any conscious volition, are constantly tracking the statistical regularities in our auditory environment. Our brains learn these pitch patterns, and consequently, these patterns are linked to our sense of musical anticipation. This implicit statistical learning lays at the crux of David Huron's arguments put forward in his 2006 book, Sweet Anticipation. In his book, Huron builds on ideas put forward by Meyer and Narmore, and asserts that music's emotive powers derive from our ability as listeners to be able to imagine, experience, and appraise our listening experience in real time, which he formalizes as his ICHPRA theory. Huron provides examples throughout his book and argues that musical choices made by composers or music makers map onto human behavior, whether consciously or unconsciously. Since Huron's Sweet Anticipation, researchers in this field have continued investigating the relationship between statistical patterns in music and aspects of perception. Some of the most prolific research in this area has come from a line of papers beginning with Marcus Pierce's dissertation, here right at City University, where he introduced his information dynamics of music model of auditory cognition, also known as idiom. Idiom is a computational model of auditory cognition that takes full advantage of a multiple viewpoints framework of musical prediction. Essentially, the model takes an unsupervised approach by learning a musical style by being trained on a large corpus of musical events. Depending on what parameters or viewpoints you tell idiom to take into account, the model will output an approximation of expectancy based on the calculated information content. In his 2018 review paper in the Annals of the New York Academy of Sciences, Pierce details many successes of idiom, ranging from modeling expectation and uncertainty, to emotional experiences, recognition memory, perceptual similarity, phrase boundary perception, and metrical inference. While in general, the model has provided a substantiated link that tethers the repetitive patterns in a musical system to that of human responses in a principled way, in line with schools of thought that inspired idiom, much of the work has focused on modeling expectation and has not been extensively applied to many aspects of memory. That said, in his review paper, Pierce notes, there's a strong link between information theoretic measures of predictability and perceived complexity of musical structure. Therefore, there are also empirical grounds for using idiom to simulate the relationship between stimulus predictability as a measure of complexity and memory for music. While Pierce cites some work that supports this hypothesis, linking complexity to memory, the studies he references deal explicitly with recognition memory using paradigms where participants make a yes or no choice based on recall using a mental model similar to the one put forward by Harrison, Collins, and Müllensiefen in 2017. While this is dependent on short-term memory, which is just one aspect of memory, a related, yet not as explored aspect of that is working memory, something that I'm particularly interested in. In this talk, I'm going to present new empirical research that links music's repetitive structure, information theory, and working memory. So in order to put forward this idea, my assertion relies on three important theoretical frameworks, two of which I've already alluded to. The first important framework is that of the implicit statistical learning. So according to Pierce, just to review, the statistical learning hypothesis, or SLH, states that musical enculturation is a process of implicit statistical learning in which listeners progressively acquire internal models of the statistical and structural regularities in musical styles to which they are exposed over a short and long time scales. This is logically followed by the second and corroborating probabilistic prediction hypothesis, or PPH, which states, while listening to new music, an enculturated listener applies models learned via the statistical learning hypothesis to generate probabilistic predictions that enable them to organize and process their mental representations of music and generate culturally appropriate responses. The last important leg of this argument then takes inspiration from David Huron's interpretation of the Hick-Hyman law, which states that mental processing time increases with the uncertainty of stimuli. Or, as David Huron interprets and paraphrases it here, processing of familiar stimuli is faster than processing of unfamiliar stimuli. If all this is then true, no leap of faith should be required to think that information content, as calculated as a result of Marcus Pierce's idiom, could be used as a proxy for the musical load on memory. The claim that I then hope to make is that there's a direct relationship between the associated information content of musical material and the material's load on working memory. Musical patterns that we hear more frequently and consequently have less information content should be easier to remember and recall compared to those that are rarer and thus have more information content. This is what I'm referring to when I refer to the frequency facilitation hypothesis. If this is the case, we should be able to find evidence of it in both a corpus of music and again in behavioral responses, two forms of evidence I'll present today. First, we examine the corpus evidence. So for my dissertation, which I defend next week, I created a digital corpus of 783 melodies from the Sol Berkowitz and Friends' new approach to sight singing. This is actually the first talk where I've been able to mention it since it's been completed, and just wanted to take this as an aside to say that if anyone is interested in a new large corpus of melodies for their own research, I'd be more than happy to talk after this talk.